very important mathematical object I call the fundamental triangle. It's not a universal term. Other people do sometimes use it, but it's going to be something that we focus on a lot. So a fundamental triangle is a triangle. A fundamental triangle, you need 2 points to form your fundamental triangle, just 2. Now the other points will, there will be one other point that's important to your fundamental triangle, and there's an infinite many points on a triangle anyway, but there are only 3 sides, right? Okay, so you want to sketch a triangle with vertices at the 2 points. Now the 2 points I gave you in class were 3, 7, and 10, 11. Now you didn't have this picture when you started out, you just had this instruction, and as I would expect, people had a lot of trouble understanding what this instruction said. Art and geometry courses don't do a good job of teaching people to read mathematical statements. But still, we'll ease into it, but we'll talk about the process. Okay, you want vertices at the 2 points. Well, that means you're going to have a vertex here and a vertex here. And the legs have to be parallel to the coordinate axes. Well, okay, if I have 2 points, and these are the vertices of a triangle, and the legs are parallel to the coordinate axes, well, that means one leg is going to be parallel to the x-axis, another leg to the y-axis. Okay? So, if these are vertices of the triangle, first thing we know, though, is that we do have a side of the triangle whose endpoints are these 2 vertices. Now we know that one of the legs is going to be horizontal, okay, going to be parallel to the x-axis. So it could be either, and that leg is going to have to go through one of these 2 points, isn't it? Because there are only 3 vertices on a triangle, and here are 2 of them, okay? If it doesn't go through one of these points, you're not going to satisfy the conditions. The leg will not have a vertex at either point. So maybe the leg goes through, maybe the horizontal leg goes through this point. That'd be okay. Okay, so there's a horizontal line through this point, and the horizontal leg of the triangle is going to have to be somewhere along this line, and it's also going to have to contain this point. And you're going to have a vertical leg, and it can't be through this point because you would not form a triangle from any vertical line segment you could draw through this point combined with a horizontal line segment through the same point. So your vertical leg is going to have to go through this point. Okay, well, there's your triangle. Here we are, and here we are. So this is a fundamental triangle through these 2 points. We could also have drawn the fundamental triangle with the vertical leg through this point and the horizontal leg through this point. This would also be a perfectly valid fundamental triangle for those 2 points. Okay, so there's the triangle. Now, we have the coordinates here. How long is this side? How long is this side? Well, we figured it out here. This side goes from x-coordinate 3 to x-coordinate 10. How far is that? That's 7 units, isn't it? So 7 units in this direction. And we could, we didn't write it out, but I'll write it out now. We're at 7 on the y-axis here, and we're at 11 on the y-axis here. Okay, everything here is perpendicular to the y-axis, all these lines. So the distance from here to here is the same as the distance from here to here. And from 7 to 11, the distance is 4. Now how do we get the distance? Well, I wrote it here. The distance is 10 minus 3, 7. The distance from 3 to 10 is 10 minus 3, isn't it? And the distance from 7 to 11 is 11 minus 7. Okay? And of course we get then 4 and 7. Okay, well that's pretty straightforward. What's the length of the hypotenuse? The hypotenuse, of course, is the angle opposite the right angle, and the right angle will be the angle formed by the horizontal and vertical legs, right? So the line segment between your vertices is going to be your hypotenuse, and you use the Pythagorean theorem. This squared plus this squared equals this squared. So that the square root of this squared plus this squared will equal this. This is the square root of 7 squared plus 4 squared. That's the length of the hypotenuse. The slope of the hypotenuse is the rise divided by the run. Now, if I move from this point to this point along the legs of my triangle, my run is 7 and my rise is 4. So the rise over the run is 4 over 7. Now, incidentally, I could have moved from this point to this point. My run would have been -7 and my rise would have been -4. Well, still the rise over the run would be -4 over -7. That's the same as 4 over 7. So it doesn't matter which point you start at and which point you end at, but you do have to take care of the signs, positive and negative. You go in the positive direction along this leg or the negative, same along this leg. We'll see more of that, and you'll see that in the worksheet. Okay. Then we ask about, well, the fundamental triangle for x1, y1, and x2, y2. Now, we don't know what x1 or y1 is. We don't know what x2 or y2 is. But if this point represents x1, y1, and this point represents x2, y2, then wherever our axes are, they might be someplace completely different. This coordinate is x1. This coordinate is x2. And on the y-axis, this coordinate is y1. And this coordinate is y2. Okay, so how far is it on the x-axis from x1 to x2? Well, how far was it from 3 to 10? Of course, we can count that on our fingers, but you can't do that with every possible numbers, every possible pair of numbers. How do we do it? Using arithmetic, we subtract this number from this number. And that not only gives us the distance, it actually gives us the displacement. If this number is smaller than this number, we'll get a negative. We subtract the first number from the second. So what we do here, clearly, if this is the x1, y1, and this is the point x2, y2, we subtract. x2 minus x1 will be this side, y2 minus y1 will be this side. Now, I'm being a little fuzzy. It should really be an absolute value if you're talking about the lengths of the sides. We'll talk about that later. Let's not worry too much about it right now. x2 minus x1 is the displacement from here to here. y2 minus y1 is the displacement from here to here. If you want to find the length of the hypotenuse, if you add the square of this to the square of this and take the square root, just like we did with the numbers 7 and 4 on this triangle. If you want to find the slope, well, that's the rise divided by the run. Now, you're given a formula, but never probably understood the formula because you didn't understand the fundamental triangle or the picture. Yeah, so we want to raise the level a little bit to where we understand it so we can use the formula for the slope and understand what it is so we never forget it. Okay, well, anyhow, the rise divided by the run is y2 minus y1 divided by x2 minus x1, and there it is. So there's the slope of the fundamental triangle. Now, the worksheet works through a lot of the details of using the fundamental triangle. So go at it. We'll talk more about it in our next class.